Good afternoon, dear students. Today the strength is less, only 7 or 6 students are there. So your exam will be starting from tomorrow, isn't it? So one small topic, so we will cover today. After that, I will tell you some of the important points uh, which should be followed. Okay, or you can say these are the instructions. Okay, for your class test. So okay, let's see the topic. So in the last class, we have seen how to find out the natural frequency or the equation of motion for a simple pendulum. So what we did, so we displaced the system, spring mass system, towards the right side with a small angular displacement of theta. So at this instant, the mass acquires velocity theta dot and acceleration theta double dot. So we will take the sign convention as on the right hand side, whatever be the motion will be positive, and in the leftward direction about the mean position, whatever be the parameters will be taken as negative. So when we applied NSL, so what we got, that the external moments will be equals to I theta double dot. So here the moment due to mg cos theta will be cancelled out because of this tension component. Only due to this mg sin theta the motion will happen, and this is the only moment for which the motion is occurring in a circular path. So mg sin theta multiplied by L will give you the moment, and its direction is leftward direction, that is why minus sign is there. So I theta double dot equals to mg sin theta into L. So if you just rearrange the term and if you eliminate the linear term, that is sin theta, then finally you will get an equation just like this: theta double dot plus omega n square theta equals to 0. So this is the equation of motion for a simple pendulum. To find out the natural frequency, so we will be using this one, omega n equals to under root g by L. So its unit is radian per second. So this is what, this is transverse vibration. Okay, so vibration is happening in this angular direction, transverse vibration. So earlier for spring mass system, the vibration was happening as a translational vibration or longitudinal vibration. So here the expression for omega and natural frequency will be under root g by L. Earlier for spring mass system, it was under root k by m. So here g is the acceleration due to gravity and L is the length of the pendulum. So from this omega n, so you can find out capital T, time period, as well as the linear frequency. Okay, so its unit will be hertz. So today we are going to find out the equation of motion as well as the natural frequency for the torsional vibration. So what is there in torsional vibration? So a rotating disc will be there. So you can see this rotating disc. So which will be connected? This rotating disc will be connected through with this fixed then through a shaft. Okay, through a shaft whose stiffness is kT. Okay, because this is torsional stiffness. So here the torsional stiffness of the shaft is kT. So earlier it is stiffness for spring mass system. Now I will be writing it as kT, k suffix t, torsional stiffness. So the moment of inertia of the disc with respect to this axis, okay, it is here, it is z, but you can use I also. Okay, so this is what This is moment of inertia. J is the moment of inertia. So this expression basically it is taken from Grover. Okay, mechanical vibration by G.K. Grover. So there the moment of inertia it is written by capital J. So you can use the letter capital I instead of capital Z. Okay. So here it is written, imagine a system considering a rotor of mass. Okay, moment of inertia. This is mass moment of inertia. There are two types of moment of inertia. One is area moment of inertia and another is a mass moment of inertia. So here I is the mass moment of inertia. So connected to a shaft of torsional stiffness KT. So as shown in figure. Now what you have to do, because this is free vibration, isn't it? So you need to give one twisting, okay, or angular deflection. So when you are giving some twisting, so theta, so whatever be the direction of this theta, it will be positive direction, and whatever be the opposite direction of theta, so all the parameters will be taken as negative. Okay, just like earlier, a torsional, the transverse system as well as the translational system. So let us consider that theta is in the anti-clockwise direction. Okay, so here you can see one arrow mark. Okay, so this is theta. So this is twisting angle. So it is twisted by an amount theta. Okay, and when you will release this one, so what will happen? The disc will rotate. Okay, so for some time it will rotate in the forward direction, means in the anti-clockwise direction, and when it will stop again, it will rotate in the reverse direction. Okay, and this will happen until any resistance will come to just stop the system, okay, or to resist the system. So unless and until that happens, the system will oscillate. Understood? So when it is in the twisting condition, so if you apply NSL, so what you will get? The external torque. Okay, and the value of external torque is what? Kt theta. Okay, kt theta. So this external torque will try to what? Try to regain the original position of the disc. Okay, means it will happen in the opposite direction. So when you will do something, so it will try to untwist. Okay, because it is having some stiffness or elasticity. Okay, so that moment which is just occurring in the system, so you need to consider that moment. Okay, so here you can see when the rotor occupies a position theta with reference to the equilibrium position, the torque acting on the rotor through the twisted shaft will be minus kt theta. Okay, so kt theta will be in the negative direction because it will try to regain its original position of the disc. Okay, so this is the external torque. So this external torque will be equals to I theta double dot, just like the previous simple pendulum example. So minus of kt theta will be equals to I theta double dot. So this is Newton's second law of motion. Now if you just rearrange, so what you will get? So I theta double dot or j theta double dot plus kt theta will be equals to 0. Okay, so theta double dot plus kt by I or kt by j, theta equals to 0. So instead of this kt by j or kt by I, so you can write omega n square, just like the earlier examples. So omega n square will be kt by I. Okay, so equation can be written as theta double dot plus omega n square theta equals to 0. Now the equation is of the same form of equation 2.3.2, means this equation is same as the simple pendulum equation, and their solution, yeah, solution is also harmonic, because this type of solution we have found out. So when we have taken the example of spring mass system and we analyze the system, so it was what? X double dot plus omega n square x equals to 0, isn't it? And for that equation we have found out the solution to be some x equals to a sine omega t. Okay, x equals to a sine omega t or some cosine function so you can convert it easily, isn't it? So this way, this will be the equation of motion for a torsional disc, and its natural frequency will be omega and will be equals to under root kt by I or kt by j. So if you are writing j, so here you need to mention that moment of inertia of the disc is I or it is j. Understood? Because j, it is basically written for polar moment of inertia, and sometimes it is written as ip also, I suffix p. That is why it is necessary to just mention what letter you are using for which purpose. Understood? So by this way, so I think you will be able to find out the natural frequency of a longitudinal system, the natural frequency of a torsional system, the natural frequency of a this one transverse vibratory system. Okay, so some similar actually expressions they all have, but little bit difference you will notice when you will write, okay, all together. Understood? So now I will be taking one example, so you can see. So very simple example. So calculate the natural frequency of vibration of a torsional pendulum with the following dimensions. So dimensions are given. So for pendulum, L is equals to 1 meter. So this is the length of the string actually. Okay, length of the string and plus the radius of the bob. Okay, so means up to the CZ. So this is the length of the pendulum. So diameter of the rod is given. Okay, rod means it is maybe one shaft. And here it is torsional pendulum. So this setup is called as torsional pendulum. Okay, so though there is no spring, though there is no direct mass, okay, so it is not showing here. So this is a torsional pendulum. Okay, so it will be having some twisting and untwisting moment. Okay, so all these things are given. Diameter of the rod is given. The rod diameter is which is having torsional stiffness kt, it is given. The diameter of the disc is given by capital D. Then mass of the disc is given. Order rotor is given 2 kg. Okay, now you are asked to the modulus of rigidity of the material of the rod is given as 0.83 10 to the power 11 Newton per meter square. Okay, so now you are asked to find out the natural frequency of vibration of the torsional pendulum. So for this system, for every system there is one. For single degree freedom system there will be one natural frequency. For double degree freedom system there will be two natural frequency, like that. So for this single degree freedom system you need to find out the natural frequency of vibration. Okay, so first what you will be finding out, the this one, mass moment of inertia. So I is what, mr square by 2, r is what, d by 2. Okay, so mr square by 2, mass moment of inertia of a solid disk will be mr square by 2. So mr, for r we will be writing d by 2. Okay, so you will get 0.01 kg into meter square. Understood? Now what you need to find out, because the formula of the omega n is what, under root kt by I, isn't it? Under root kt by I. So I you have found out, but kt it is not given in this question. Kt is not given. So to find out kt, so some of the things we need to use actually. So how you can be find out the value of kt? So the formula for kt will be, so from strength of material what you have studied, T by J. Okay, T by J or IP, here it is written T by J. See, if you write the J, so you cannot write J here because this is polar moment of inertia. Here they are writing IP. Okay, so earlier the formula was T by J equals to Z theta by L, isn't it? Tau by R, T by J equals to Z theta by L. This is the formula for from strength of material. Okay, all of you, I think you can remember. Okay, so instead of J, here it is written IP. Okay, so if you write here I, okay, inertia, moment of inertia, then you can easily write here J. But here they are not writing J because they have already used this letter J. Okay, or mass moment of inertia. So that is why they are writing IP, polar moment of inertia. So Z theta by L. So from here, so you will be able to find out the value of this KT. Okay, So kt will be what? Kt will be t by what? Theta. Because see, why kt will be t by theta? Spring force is what? F equals to kx, isn't it? So torque will be equals to what? Kt into theta. So t equals to kt into theta. So kt will be what? T by theta. Okay, so t by this theta will be equals to kt. Understood? Yes, because the spring constant k is what? F by x. So kt will be what? T by theta. So equals to z, ip will go here and l will be remain as it is. So z ip by l. So kt value, so z value is given, modulus of elasticity. So I value is what? Pi by 32 d to the power of 4. But this is small d to the power of 4. This ip is for this polar moment of inertia is for this shaft, not for this disc. And this moment of inertia is for this disc. Understood? This polar moment of inertia is only for the shaft. Okay. So pi by 4 d to the power 4. Understood? So pi by 32, pi by 32 d to the power 4. So this will be small d. Okay. So 0.005 meter. So as it is in millimeter. Okay. So now you will be able to find out the value of kt. So applying both these values I and kt, so you will be able to find out w, okay, or omega n. The natural frequency will be under root kt by I. Understood? So this is the angular frequency 22.6 and this is the linear frequency, okay, 36 hertz. Okay, so very simple problem. So thus you will be able to solve this kind of problem. These are the very basic things of the mechanical vibration. So I think there is not much complex things which you are you will not get after studying up to this much. Okay, so dear students, actually the exam related things, some of the exam related things I want to share with you. See, so this exam will be of 40 marks. Okay, class test exam will be of 40 marks. So yeah, so there the question paper, in the question paper there will not be any objective type question, so it will be on a descriptive type question. So questions will be, marks will be ranging from 5 to 10. Okay, maximum marks for a question may be 10, okay, not more than that, and minimum 5. Okay, so 6-7 questions, 5-6 questions will be there in your question paper. So you need to complete those in the time frame. I don't know how much time it will be given. I think it is 2 hour or okay, so like maybe 1 hour and a half also. So I don't know about the time duration. Okay, so you,
It's 3 hours.
yeah, 3 hours. Okay, okay, so in
Yes,
that
sir.
time, yeah, time you need to actually complete, and syllabus will be up to today's class. Okay, so up to today's class you need to study actually. Okay, so whatever you will be uploading in your in this platform Google, in the Google Classroom, I will be uploading the question paper. So whatever answer you will be uploading, just write, okay, write with a black ball pen if possible, okay, and it with distinct letters, just you write distinct handwriting, you just write, and font size should be little bit means distinct and clear, okay, so that I can read easily. And if there are some figures in your writing, then draw this by pen, okay, black ball pen point, okay. And if you want to use scales, then also you can use the thing, but those things should be clear and visible, okay. And when you are taking the photograph, so your paper and your phone, okay, that should be parallel. Okay, sometimes some wide angle these projections will be there. Sometimes that thing, it is very much, that time it is very much difficult, okay, for the examiner actually. So if you want to ask anything, you can ask. uh, so that question, someone has raised one question actually. See, the PDF, whatever you will be uploading, that thing, okay, just keep with you, that soft copy. So if it is asked in future to submit to the college authority, then you have to submit, okay. That is why whatever you will be this answer scripts, whatever be your answer script, just you make one folder and you store it, okay, in your computer, whatever it is possible. And if it is asked in future, then yeah, definitely you will have to submit that one if it is asked from the management. Okay. So syllabus is up to today's lecture. Anything you want to ask? Rajdeep, Shivano, Janata, Vedo, Bhaskar, Manas.
Sir, numerical
Sir,
any কেইটা আহিব ন sir?
কোন ৰক্তিমে সুধিছা?
হয় sir.
নিউমাৰিকেল থাকিব, দুটামানটো থাকিব, দুটা তিনিটামান থাকিব। Actually, yeah, actually, this subject is basically numerical based subject, but as because this is your first class test, that is why so you will get both the things, the theory part also and the numerical part also. And I also actually forget how many numerical problems I have given in the question paper, okay, because it was set few days back. But yeah, up to this much, if you have gone, if you will go through the video lectures and the class notes, okay, so you will be able to solve if your concepts are clear, okay, till now whatever things I have given to you. So if you follow those things, then I think you will score good marks. Yeah, Porimal.
yes, sir.
Now I think everyone is okay. I heard the Porimal. Yeah. How is your health, Porimal?
So it's good.
Now it's good now. So you
Yes,
have
sir.
tested negative.
Yes, sir.
Okay. And what about Manas? Manas, how are you feeling now?
Sir, well, sir.
All
Well.
right. All
Yes,
right.
sir.
Okay. Okay.
Yes.
Good. Good. All of
Sir,
you are
syllabus
young
will
and
be
yeah.
class, no, sir?
Huh?
Sir, class test syllabus will be today's class, no?
Yeah. Yeah. Up to today's class, your syllabus for class test 1. Okay. So study well, okay, prepare for the exam, and my best wishes to you. If you find any please be there. If you find any difficulty, okay, so you can ask the doubts, through WhatsApp also, okay, in my personal WhatsApp, just ask the doubts, okay. Yeah, thank you, your students. Now you can leave if you want, okay, and if you want to ask anything, you can ask now.
Thank you sir.
Yeah.
Thank you sir.